So in today's video, we are going to see binary search tree. So which is nothing but BST. So BST is a special type of binary tree that maintains a specific ordering property. In a BST, for every node in a tree, the left subtree contains only nodes with value less than the node value, and the right subtree contains only node with the value greater than the node value. So these two are very important. Suppose we are taking this as example. So I am constructing a binary search tree. We take the first number 50. We take second number. So compare with the root node. Root node is 50. Current value is 30. So less than 50. So that's why it comes as a left child of that particular node. Then we are taking 70. Compare with 50. Greater value. So it is a right child of that particular node. We are taking next number 60. Compare with root node 50. Greater value. Compare with 70. It is lesser value. So that's why 60 comes here. 80 compare with 50 greater, compare with 70 greater value. So that's why 80 comes here. Next number is 40, compare with 50 lesser number, compare with 30 greater value. So 40 comes as a right child of 30. And 20, compare with 50 lesser value, compare with 30 lesser value. So it comes here. After constructing a binary search tree, suppose we follow the in-order traversal. In-order traversal, it is nothing but left child, root node, right child. Suppose we follow the in-order traversal. We are able to get a sorted value in sorted order. 20, 30, 40, 20, 30, 40, then 50, 50, it is nothing but left, top, right, 50, then right, when we come to right, again left is there, so that's why 60, 70, then 80. So after taking the number through in-order traversal method, we are getting the sorted value. So this is, we call it as BST, that is binary search tree. So now you come to the definition. In BST, for every node, it is a left subtree contains only node with values less than the node's value. Suppose I am taking the node 50, all the left values, left side values, all are less than this value. All the right side values, all are greater than that value. So that is what it is given, left subtree and right subtree. Left subtree, all numbers are less than that node. Right subtree, all numbers are greater than that node. So it maintains in each and every level. Suppose I am taking this value 30, left hand side left smaller value, right hand side greater value. So through this way only we are constructing the binary search tree. Keep in mind that binary tree is different, binary search tree is different. So this is, we call it as BST. What is binary tree? In a binary tree, we follow only one property, that we are taking the first number 50 as a root, we are taking second number, it is left subtree, we won't bother about value. In 70 it is a right child, then 60 it is a left child of 30, then 80 is a right child of 30, then 40 is a left child of 70, 20 it is a right child of 70. So this is what binary tree. In a binary tree, we are filling the levels, we are filling the nodes level by level. So it is level 0. So start from level 0, we fill two values, left child, right child. And we are taking this level, left child, right child. We won't bother about the value here. Whereas in BST, we are following the binary tree property as well as we are following the binary search tree property. So the binary tree property does each and every node have only maximum 2 children, and for each and every what is that level, what is that smallest value it is in left hand side, greatest value in the right hand side. So this is the major difference between BST and binary tree. So now we come to the time complexity. As far as the time complexity is concerned, in a best case, there are three operations we are doing according to BST. One is search operation, another one is insertion operation, another one is deletion operation. Best case, all search, insertion and deletion, the time complexity is big O of log n. Whereas in the average case, it is also same as best case. Both best case and average case, all three search, insertion and deletion, the time complexity is big O of log n. Whereas we come to the worst case, worst case, search, insertion, deletion all are comes under the big O of n. What do you mean by worst case? Worst case, it is nothing but suppose numbers are given like this, we are forming a balanced binary tree. What do you mean by balanced binary tree? If left having 3 children, right is also having 3 children, and this type of tree it is called a balanced BST. Whenever the tree structure it is balanced BST, balanced binary tree, binary search tree, then it comes under best case or average case. If it is imbalancing, in that case what we do, we are comes under the worst case. For example, we are taking one more example here. Suppose the numbers are 20, 30, 40, 50, 60, for example. So in that case what happens means, we are taking 20, it is defined as a root. Then 30, that is a greater value, so that's why it comes as a right child. And next number is 40, it is greater value than 20, then 30, so that's why it comes as a right child. 50, that is also greater value, 50 comes here. Then 60, 60 also it comes here. So this type of tree it is called a not imbalanced tree. This is, we call it as skewed tree. So whenever the skewed tree it comes under the worst case. In this scenario, we are finding any value in that, we go for big O of n times, because we are searching in the one branch only. There is no left branch here for each and every level. So in this case, it comes under the worst case. Suppose I want to insert one number. Suppose I want to insert some 80. What is that? We go for all numbers, and after 80 only, after 60 only, 80 it is added here. So this operation for inserting the operation, it takes big O of n time. Okay. So whenever the tree is skewed tree, so it comes under the worst case. Okay. So I hope you understand the logic of binary search tree.